Hi students, this is Karthik Trivedi and you're watching a lecture series of engineering graphics and design with me. So in today's video, we're gonna start a new chapter called loci of points. So what we will do, first we will define what exactly the loci of point is. So let us see the definition of loci of points. So as you can see the definition on your screen, the locus of a point is the path traced by a point as it moves in accordance with set conditions and constraints. So here title is loci of points, but here the question comes in your mind, sir, you are talking about the locus of point. Why I am talking about first locus of point? Because here you can see the second point on your screen. The plural of locus is loci. So when you are talking about the loci of points, that means you are talking about so many locus of point P. Okay, and so plural of all these locus is known as loci. So loci is a plural form of locus. So first what you have to do, so here the definition is locus of a point is the path traced by a point as it moves in accordance with set condition and constraint. So let us take one example. Let us say you have a crank and connecting rod mechanism. So I think some of the mechanical engineering student and automobile engineering student will go to know what here I am talking about. But those who are in computer engineering, I think they also knew about it, because they have a subject called EME, Elements of Mechanical Engineering, or Basic of Mechanical Engineering, where you have studied for a crank mechanism, crank connecting rod mechanism. And those who don't know about crank and connecting rod mechanism, I am just giving you what you have to do. I am giving you one advice, that just go to the Google and write crank connecting rod mechanism and just see it. Take a 2 minutes of that and then come on to this video so you can better understand this video. Okay, so in crank connecting rod mechanism, what exactly is happening? Crank is rotating. So what is exactly there? There is a connecting rod which is connected to the crank. So crank is doing rotary motion, and one end of the connecting rod is connected to the crank, and other end of the connecting rod is connected to the piston, or you can say connected to the slider. Okay, so other end is connected to the slider. Okay, so now this kind of mechanism is over here, and the slider is doing reciprocating motion. So the motion of slider is very constrained, and the motion of the slider is only like this, like reciprocating. Okay, so motion is having a constraint, is doing in a particular way. Same way crank is doing rotary motion. So when you have this kind of mechanism where some constraint is over there, or where there are some set of conditions, so according to that the mechanism have to perform. So in this kind of mechanism you have to find a locus of some particular point, whether what kind of point that they will give you in example, but you have to find locus of point. And when you find so many locus of this kind of point, so plural form of so many locus of point. So when you're talking about so many locus of point means plural of locus, that means you are talking about the loci. So this is called loci of point. So now in this definition you will not understand what exactly I am here trying to say, but to understand it properly we have to take one example, and through that example you will understand what exactly is loci of point. So again we will come on to this definition. First I will teach you the example, and through example I am going to clear the concept of this definition. So let us understand this definition through one example. So see the example on your screen. So example is, in a slider crank mechanism, the connecting rod, or you can say the connection of rod, is 160 mm. So here he has written connection of rod, that means he is talking about the connecting rod. So here the length of connecting rod is given, which is 160 mm, and crank is 40 mm in length. So dimension of crank is given. So crank is 40 mm. First write given data on your sketchbook. First write connecting rod is equal to 160 mm. Then write crank is equal to 40 mm. The other end point of the connecting rod on the slider. So we know that the connecting rod is having one end connected to the crank and another end connected to the slider. So what he is trying to say, that the other end point of the connecting rod on the slider moves along the straight line passing through the center of crank rotation. Trace is the locus of point P of the connecting rod. Sometime he will just write this kind of example only. He will not give you a figure, but in some kind of university paper paper you can see this kind of example, and also figure is given there. So this kind of figure also he is going to give you, so that you will get to know what exactly mechanism is, what type of mechanism is over there. So in example, you have this kind of statement and you have this kind of figure. So what is trying to say that here you can see that the OA is crank. So first we will define. So OA is the crank, so which is doing rotating motion. Now what is connecting rod? So here you can see that the AB, the line AB, which showing the connecting rod AB. So this is the connecting rod AB. So first you have to understand what exactly this mechanism is. The OA is the crank, which is crank OA. The AB is connecting rod AB, and you can see the slider. Where is the slider? So you can see that slider. So you can see the one of the point B is written over there on the slider, and what you can see the some incline line. So incline is showing the fixed position. So what it shows that slider is doing sliding motion in cylinder, some cylinder. So slider is exactly in some cylinder, okay, and in which a slider is doing reciprocating motion. So you can see that some incline line. So incline line is showing that there is some fixed thing over there, and into this a slider is doing reciprocating motion, something like this, okay. So when I'm talking about the slider, you don't have to see this incline line. This incline line is nothing but it's showing some fixed thing. Let us assume cylinder over there, and you can see the slider is something like you can see the rectangle form, okay. So you can say point B is written over there. So assume that this is the slider is something like rectangle, okay. So assume the square like thing over here. So what is exactly happening over here? That is some cylinder, and the slider is in cylinder. So slider is doing sliding motion in the cylinder. So here the incline line is given. So incline line is showing that is this some fixed thing over there, and into this fixed thing the slider is doing a sliding motion, okay. So now let us solve this example. So first you can see that first we have to draw one circle. So circle of which kind? So we know that the crank OA is doing rotating motion. So what we have to do? We have to circle equal to the radius. So equal to the dimension of crank OA. So crank OA is how much mm? 40 mm. So first we have to draw a circle of 40 mm. Radius equal to 40 mm. So first we have drawn this circle having a radius equal to 40 mm. Why? Because crank OA, the dimension of crank is given, which is 40 mm. So we know that the crank is doing rotary motions. So we have to draw first a circle of radius 40 mm. Now let us divide this circle into 8 number of equal parts, something like this. And now let us assume that the crank OA is doing a rotation in anti-clockwise direction. So let us give numbering something like this: A1 in anti-clockwise direction, A1, A2, A3, A4, A5, A6, A7 and 8, which you can see on your screen. Now you can see the center of the crank. So that means you can see the point O is over there, okay. So point O and the slider center position. So you can see the slider center line is point B is written over there. So you can see the slider center line. So point B is showing the slider center line, okay. So you can see the point O and point B both are on the same center line, okay. So that you have to keep in mind. Now what you have to do? Now first we will draw a one center line through center of this circle. So let us draw a one center line through center of this circle. So you have to draw some random horizontal line, something like this, from the center of this circle, okay. Now what we have to do? We have to mark the position of connecting rod. So here the dimension of connecting rod is given 160 mm. So you can see that the first one end of the connecting rod is connected to the crank OA, and other end of the connecting rod is connected to the slider, which is here mentioned at the point B. So what you have to do? Now we have to mark the position of connecting rod on the center line, other end of the connecting rod on the center line. So what we have to do? As you can see on your first figure, that the other end of the connecting rod lies on the center line, which is point B is written over there. So what you have to do? From point A1. So this is the, when I'm talking about A1, that means there is one particular position of the crank A1 at some time. Now after some time the crank will move to the position A2. After some time the crank will move to the position A3 up to A4. This is something like this. So let us say right now the crank is at position A1. So let us mark the connecting rod, other end of the connecting rod on the center line. So we know that the dimension of connecting rod is 160 mm. So what you have to take a divider, take a distance equal to 160 mm, and A1 as a center. So come on to the A1 on a circle. So A1 as a center, put an arc on the center line. Whenever it intersect, it will be your point B1. And now what we have to do? We have to find the locus of midpoint of the connecting rod. So A1 B1 is 160 mm. So mark point P1 which is at 80 mm from A1 or 80 mm from B1, because we have to find the locus of midpoint of connecting road. So A1 B1 is 160 mm, so point P1 is at 80 mm either from A1 or either from B1. Now we have to do the same procedure at a different position. So now come on to the A2. Now you know that connecting road is equal to 160 mm. Take a distance equal to 160 mm in your divider. A2 as a center, put an arc on a center line, something like this. Whenever intersect, it will be a point B2 and mark point P2, which is midpoint. So you know that A2 B2 is 160 mm, so point P2 is 80 mm. So either it is from 80 mm from A2 or either it is at a 80 mm from B2. So this is how you have to mark the point P2. Okay, why we are marking the point P2? Because we have to find the locus of the midpoint of the connecting road. Okay. Now for A3, same thing. What you do to take a distance equal to 160 mm, put an arc on the center line. Whenever intersect, it will be a point B3 and mark point P3. So it is, we know that A3 B3 is 160 mm, so point P3 will be 80 mm. Okay, either from A3 or either from B3. Same way from point A4, what you do, take a distance equal to 160 mm, put an arc on what? On a center line. Whenever intersect, it will be a point B4 and find point P4, which is 80 mm. Okay, because it is a midpoint of A4 B4. Now same for the from the point A5, what you do, take a distance equal to 160 mm, put an arc on a center line. So A5 as a center, put an arc on a center line like this. Whenever intersect, it will be a A5 B5. Give the point B5 and find the midpoint P5. Now what you do, now from point A6, take a distance equal to 160 mm. So A6, take a distance equal to 160 mm. A6 as a center, put an arc on a center line. Whenever intersect, it will be a point B6 and find a midpoint P6. Now from point A7, same way, from point A7, what you do, take a distance equal to 160 mm. A7 as a center, put an arc on a center line. Whenever intersect, it will be a point B7 and find midpoint P7. Now from the last point A8, so what you do, take a distance equal to 160 mm. A8 as a center, put an arc on a center line. Whenever intersect, it will be a point B8 and find the midpoint P8. So now what you do, we have to find the locus of midpoint P of the connecting node. So we have the midpoint P1, P2, P3, P4, P5, P6, P7 and P8. So what you have to do, you have to connect all the midpoints. So from P1 to P2, P3 to P4 up to P8 by a smooth curve. So let us do like something like this. Okay, so we have connected all the point P1, P2, P3, P4, P5, P6, P7, P8 by a smooth curve. So this is known as the loci of points of a midpoint P. So now here you can see that through definition there is some mechanism having some constraint over there, and we have to find the locus of something. So here we have given, you have to find the locus of the midpoint of the connecting road. So you can say that here one locus is point P1 of a connecting road O1 B1, but it is not only one locus over here. You can see the connecting road A2 B2 and A2 B2, and there is another midpoint of this connecting road which is point P2. So there are so many locus. So here P8, so here 8 midpoint locus of the connecting road. Okay, so if you connect taking these so many locus, so plural form of locus is called loci. So that's why this chapter is known as loci of points. So now I think you can understand what definition is trying to say over here. So let us again go through the definition. So definition is locus of point is a path traced by a point as it moves in accordance with set condition and constraint. So here we can see that we have seen the crank and connecting rod mechanism where we have some constraint because slider is doing reciprocating motion only. And what we have done, we have find the midpoint of the connecting rod, and there are so many connecting rod. So according to that, we have to find their midpoint, and we have connected all this midpoint by a smooth curve. So there are so many midpoints, not only one. So that's why here written the plural of locus is called loci. So that's why this is known as loci of points. So I think now you'll understand what exactly the loci of points. I hope you will like this video. Have a nice day. Bye bye.